So we'll start this lecture by focusing on database management. Now, databases play a critical role in web app development. It's one of the most important aspects of building an application. The web application interacts with the database to store data and then retrieve data from it. Now, the database is used to store all the information that the user needs to store. So, for example, if you're developing a shopping cart website, then it'll contain product details, customer details, order details, so on and so forth. Now, in this case, you'll need to store this information in a database so that we can use it later on. And some of the learning objectives for this particular module will be to design a normalized relational database schema, create and manage a MySQL database on a remote host, and then write SQL commands to create tables and define relationships. Now, the process of database design typically involves the following steps. One is to determine the purpose of your database. And this is going to help you prepare for like all of the other steps that we're going to follow. The next one is to find and organize the information that's going to be required. So we're going to gather all of the types of information that you might want to record in your database, such as a product name or order number. Then the next step is to divide the information into tables. So we divide our information items into like major entities or subjects, such as products or orders, and each subject then becomes a table. The next step is to turn that information into items, into the information items into columns. So we decide like what information we want to store in each table. And then each item becomes a field and it's displayed as a column in the table. So, for example, an employee's table might include fields like last name, first name, date of birth, hire date, so on and so forth. These are like aspects of or attributes of our entities, or they would be things that would describe our entities or describe, the subject of our tables. The next one is to specify primary keys. So we choose each table's primary key. Now, the primary key is a column that is going to be used to uniquely identify each row or each record within our table. So, for example, if we have a product table that's got product information for a record, the product ID would uniquely identify it. If you had an orders table, the order ID would uniquely identify it. Then the next thing would be to set up table relationships. So we look at each table and we decide how the data in one table is going to be related to the data in another table. And then we add fields to tables or we create new tables to clarify the relationships if we need to. The next step is to refine your design. So you're going to analyze your design for any errors. You're going to create the tables and then add a few records of sample data. This is to see if you can get the results you want from your tables. And then, of course, make adjustments to the design, as needed. And then the last step would be to apply the normalization rules. So we're going to apply the data normalization rules in order to see if your tables are structured correctly. And then we make adjustments to the tables, as we need to. Now let's talk about relationships and ERDs. An ERD, or an entity relationship diagram, is a diagram that displays the relationship of entities stored in our database. In other words, ER diagrams help to explain the logical structure of the databases. ER diagrams are created based on three basic concepts: entities, attributes, and relationships. Now, ER diagrams contain different symbols that use rectangles to represent entities, ovals to define like the attributes, and then diamond shapes to represent like relationships. Now, an ER diagram looks very similar to like a flow chart. However, ER diagrams include, many other specialized symbols, and its meanings make this model kind of unique. Now, the purpose of an ER diagram is to represent the entity framework infrastructure. So, part of the assignment this week is actually creating an ER diagram to diagram as far as milestone 3. So I want to just do a little demo of how you would create your diagram. I'm not going to do the one that you're going to do. You're going to create one based on like for the events website that you're creating, but I'm just going to do a simple one. And you can actually use, there's different applications out there. Lucid Chart is one, Draw.io is one, and even create it on pen and paper. But I'm going to supply you with a template for PowerPoint. I've created the ER diagrams and using PowerPoint because you are able to actually do um, the shapes and with the shapes that comes with PowerPoint. So this is the PowerPoint that I'm going to provide for you in the course room. And like I said, what you do is you use different symbols to represent the different elements. And doing when you're creating a database, it's always best to plan out your database before you actually start building it in the MySQL interface. So one of the things you want to do is you want to think about, let's go back to, you want to think about as far as what the entities are going to be. These are going to be your real world objects. These are going to be the things that you're going to be that are going to end up being your tables within your database. So you have to kind of think about what those would be. So here we've said that your key entities in your assignment would be your users, which we're going to be storing information about the users, we'll be storing information about the events, and we'll be storing information about the registrations. We're kind of keeping it simple. So you want to think about, like, again, these are going to be our key entities that we're going to identify. These are going to be our tables that we work on. And then what you want to do is you want to think about, okay, so you've thought about your tables, then you need to think about the attributes. And the attributes are the different characteristics that are going to describe your entity. So what are the things that are going to be describing your users? For instance, they'll have a name, and we'll break a name down to last name, first name, middle initial, something like that. They'll have an email address. Events will have a name, a date, a location. Registration will have a user ID, an event ID. So these are all the things that we're going to diagram within our ER diagram. We'll also diagram as far as relationships, and we'll talk about as far as like the different ratio constraints, the cardinality ratio, of um, how the different entities are going to participate into that. I don't want to get too complex because we're going to keep it very high level as far as the database, because I really, for this class, the concentration really is as far as on the PHP. So let's go ahead and switch over to our PowerPoint, and let's design just for a basic, I'm going to do a school, like a real basic ER diagram for a school. Okay, so within a school, and the way that you use this, you can copy this and then paste it, to get, but each of our entities is going to be represented by a rectangle. So I'm going to have 3 entities. Okay, and I'm going to have student. Okay, normally when we do entities, we put them in capital letters. I'm going to have um, teacher, and I'm going to have course. Okay, and these 3 will have a relationship with each other, and so before I get into that, we'll do as far as like the different, remember I said the attributes, so we'll do the characteristics, of students. So let's grab and I'll say last name. And I usually do attributes. We try to keep those like maybe camel case or something. Okay, copy that. Um, First name. I'm going to keep it kind of high level. Copy that. I'll say date of birth. And then we always want to have that unique identifier, something that's gonna, we talked about briefly, primary key. I'll go into, primary keys more in a bit, but we're going to be using a student ID as the unique identifier. And so then all we do is we connect these with lines. I should have did black. I guess it doesn't matter. Okay. Okay. And then we'll do the same for teacher. We'll just come up with, we'll just say first name. Of course, they'll have a first name. We'll say last name. Um, and we'll say faculty ID. Now, on ER, and again, without getting into too much complexity, but ER diagrams, what we like to do is whatever the unique identifier is going to be, we call that the key attribute. That's going to be underlined so that we will know that that's going to be the unique identifier. So let me go ahead and now connect my attributes to teacher. Okay, and then course, I'm going to have I'll have a course name. To stretch that out a little bit. I'll have maybe course number. That's all I'm going to have. I'm not going to. And this, of course, is going to be my unique identifier. Okay. And let me go ahead and connect these. Okay. And now these three entities are going to have a relationship. So I'm going to use the diamond for that. And I'm going to show student has a relationship with teacher. Okay. And basically that relationship, and usually use like maybe an action or something like that to describe it. And I usually put these in capital letters also. So it's teacher teaches the student. That's the relationship. Okay. Copy that. Okay. And then I'll have a student takes or enrolls in something like that. Yep. Okay, and so then I'll have my lines for that relationship. Move this over a little bit so it's not in the way. Okay, and even there's a relationship between teacher and courses, which again is teaches. Okay. So this is how you're going to design as far as your ER diagram. Now, I can get a little bit more specific, which will help me when I'm designing my database, for my application. Um, is to talk about as far as like what's the maximum number of instances that that an entity can participate in this relationship. And so there's different what they call cardinality ratios. There's like a 1 to 1, so meaning that would be one student per one teacher, one to many, many to one, and many to many. I'll provide a little bit more information about this, but basically what we would be saying is that in this particular instance of this course, maybe how many times is the student, or how many students are taught by a teacher. So, I could say, depending on my business rules, I could say that it's one teacher to many students. Okay. And then, you know, um, in this relationship that I'm establishing, I'm saying that, um, well, actually, no, it wouldn't be. So it would be many. So I'd say um, many students are enrolled in different many courses. So basically, students are enrolled in many courses, and many courses can have multiple students, and then here the same thing, depending on the business rule, it may be, that maybe only one teacher teaches a course, you know, um, you have many teachers that teach a course, depending on what the business rule. Like I said, you don't have to really do as far as the ratio. I'll provide a little bit more information about that. All I'm really looking for the assignment is, for starters, is just to um, provide as far as the relationships and the entities and the attributes, and that's going to help us to build that database. So you're going to be basing you building the database based on your ER diagram here. So you'll be creating it for, like I said, for your events. You'll have, events, you'll have users, and then you'll have registrations, and entities. Keep in mind, entities are objects. They're real world objects. They can actually be physical things, like things we can touch, feel, and see, or they can actually be concepts, like a course is a concept. Um, an event is a concept, a registration is a concept. So you'll build something similar to this for as far as your events database, and then you're going to build out your database. So I'll show you how to build out your database, how we'll be building our database in a bit, but I wanted to just show you, give you just a little bit of an example, a demo of how you actually be building out your ER diagram. So let's do a quick database 101. Okay, so let's talk about the different types of databases. So there's several types of databases. Some are more commonly used, categories of databases might include a hierarchical database. And this database follows the progression of data being categorized in ranks or levels. Then there's the relational databases. And this database is commonly uses like structural query language, or SQL, for operations like creating or reading or updating or deleting data. We call those like CRUD operations. MySQL, Microsoft SQL Server, and Oracle are a few examples of a relational database. Then there's the non-relational databases, and these are commonly referred to as like no SQL databases. And some examples of these would be like the MongoDB or the Redis. And then there's object-oriented databases. And in an object-oriented database, databases organized into objects, which are like self-contained entities that contain both data and the method that operates on that data. Now we're going to focus on relational databases, and we'll be using MySQL, for our projects in our demos. Okay, so let's talk about the different parts of the relational database. So tables are an essential object in a relational database because they hold all the information or the data. So for example, a database for a business can have a contact table that stores the name of the suppliers, their email addresses, and maybe their telephone numbers. Now, before you start creating a table, you got to consider all of the requirements and determine, all the tables that you might need. Now, each row is more correctly called a record, and each column is called a field. So, a record is a meaningful and consistent way to combine information about something. A field is a single item of information, an item type that appears in every record. Now, in the production table, for instance, each row or record would hold information about one product. And each column or field is going to hold some type of information about that product, such as the name or the price. Now, let's talk about the primary key. So each table should include a column or a set of columns that uniquely identify each row stored in that table. Now, this is often a unique identification number, such as an employee ID number or a serial number. Now, in database terminology, this information is called the primary key of the table. Primary key fields can quickly associate data from multiple tables and bring the data together for you. Now, if you already have a unique identifier for a table, such as a product number that uniquely identifies each product in your catalog, then you can use that identifier, as your table's primary key. But only if the values in the column will always be different in each record. You cannot have duplicate values in a primary key. For example, don't use people's names as a primary key because names are not unique. You could easily have two people with the same name in the same table. Now, we'll cover more database structure and elements, a little later. But the next thing I want to talk about are data types. So a database table contains multiple columns with specific data types, such as numeric or string. Now, MySQL provides more data types, other than just numeric and string, though. Each data type in MySQL can be determined by the following characteristics: the kind of values it represents, the space that it takes up, whether the values are fixed length or variable length, the values of the data type can be indexed or not, and how MySQL compares the values of a specific data type. Now, in MySQL, you can find all the SQL standard numeric types, including integer, fixed point, and floating point. Now, MySQL does not have a built-in Boolean or a Bool table type, a data type. So to represent like a Boolean value, which would be like a true or false, MySQL uses the smallest integer type, which is the tiny int. So in other words, like the Booleans are synonyms for a tiny int in MySQL. Now, in MySQL, a string can hold anything from plain text to binary data such as images or files. Now, the most common string data type that you might use in the project that we're working on is a varchar, which is a variable length string whose length can be up to 65,535, or a text type, which is useful for storing like long form text strings that might be found as maybe an article body for like a news site or a product description or something similar to that. Now, MySQL provides types for date and time, as well as the combination of date and time. In addition, MySQL will support the timestamp data type for tracking like the changes in a row of the table. So if you want to store maybe years without dates and months, you can use the year data type. Now, you should decide on which data types you need to store your data. For example, if you're going to store a phone number as a string with their dashes, or if you're going to store them as numeric, then in that case, they would be an integer. So a good database design should avoid redundancy by having different fields. The table should be constructed following standards and conventions, and this includes naming conventions and structures. So let's look at this. So you need to divide your information into subject-based tables in order to reduce redundant data. You're going to provide access with the information it requires to join the information and the tables together as needed. You're going to help support and ensure that the accuracy and the integrity of your information. And then you're going to accommodate your data processing and reporting needs with whatever your design is. Now, MySQL is an open source relational database management system. It's the most popular database system used with PHP. Now, MySQL is developed, distributed, and supported by the Oracle Corporation. Now, the data in a MySQL database, they're stored in tables, which consist of, like we talked about, columns and rows. MySQL is a database system that runs on a server, and it's ideal for both have a small and a large application. It's very fast, it's reliable, and it's easy to use. And it uses standard SQL. And then it compiles on, say, a number of different platforms. Okay, so also part of this milestone is you're going to take the ER diagram that you've created in step 2, and you're going to actually set up your database, and you're going to create the table. So I provided some instructions as far as some videos um, on YouTube about setting up the database, and then also some a, a PDF about as far as the tables. But I do want to just kind of walk you through it a little bit, just to help you if I can. So um, when you go to log in to your Infinity account, you'll see your website here. So you're going to go ahead and you're going to click on that website, and this would manage our actual website. But what we're doing is we need to create a database. So we're going to go in and we're going to create a database. So remember, you need to kind of have your database planned out. That was what the ER diagram is going to do for us. But from the account options, you're going to click on MySQL databases. And you need to make a note, of all of this different information that it's providing here. Go ahead and look at the MySQL password, because this is information that you're going to need when you go to connect your PHP um, website to your database. Okay. All right. So what we're going to do is we're going to create a new database. So we click on Create Database. And then here we're going to give our database a name. And so I'm just going to say, I'm going to call mine school. And notice the prefix here, that is the entire name. Okay, so what the web host does is it prefixes your database name. So you're going to make a note of that entire name. So whatever the prefix is, underscore, and then whatever you've named it. And then go ahead and click Create Database. Okay, it says not valid. What is it? Maybe I need to have a lowercase s. Okay, so you have to put lowercase letters. Okay. All right, so now when I come to my SQL databases, it's going to list my databases. And I'm not sure how many InfinityFree gives you. If it gives you a couple of them, then maybe you can use one just to play around with, and then one that's actually going to be part of um, your information. So again, your project. So again, just make a note of the entire database name. Make sure that you made a note of all of the username and the host name, and the port and everything else, because like I said, you're going to be using these coding your connection later. Now, like I said, once we've built our databases, then you'll notice it under here as well. And so we'll go ahead. What we want to do is we want to go ahead and start working with our database. And so each host company does something different. I've noticed um, Infinity Free. This is where you'll get your list of databases. So when you go into MySQL, it's going to be specific for that database. So anytime you need to, if you do need to change out and go to another database, you're going to have to come back to this screen here. You'll come back to this one, but this will open a new tab for us. So let's go ahead and click on my phpMyAdmin. This is going to launch the web interface that we're going to be using to interact with our website. I mean, with our database. Okay. Now, again, a lot of web hosts, when they do integrate with PHP, my admin, what they'll do is they'll have like a left panel here, which will have all of the different databases for you to kind of go between each database. This one I noticed doesn't do that. So, you're in the database that you're working with. This is how you know the database that you're working with. If you ever kind of come out of that, like I've accidentally clicked on this, then you have to go back to that tab and then relaunch as far as my SQL, I mean my PHP admin in order to be able to get back to this. Okay. All right, so this is the interface that we're going to be working with. We're going to actually create a table. Right now it's saying no tables found in database, but we're going to create a table. Okay, so um, for this demo, I'm going to work on, I'm just going to do a sample. Like I said, you're going to base your tables, you're going to have maybe those three tables: event, registration, I forgot what the other one was. Let's see, users, events, registrations. Those may be your three tables. And like I said, you're going to have through your diagram, you're going to know like what columns you're going to be creating, what fields you're going to be creating based on the different attributes. But I'm just going to show you just an example of creating a table, and then what you do is you apply this to as far as creating your three tables. So the first thing is I'm going to give it a name, and actually you can tell I've done this before. So my table name is persons. Um, and again, I always do an underscore T so that when I use it in my code, it knows that I know that this is a table name that I'm working with. And then it's going to also ask you as far as like the number of columns that the table should have. This means, again, you need to look at your table design within your model and start thinking about like how many tables, how many columns, how many different attributes you have, and then that would be how many columns you have. I'm going to leave mine at the default of 4, and then I'm going to go ahead and click on Go so that it can create the table for me. Okay, so now with this, what I can do is I can go ahead and configure the structure of my columns in my new table. So, I would enter, say, the name of the field. Um, Now, the first one here, as we talked about, each table record should have a unique identifier, referred to as the primary key. And this allows us to have that unique reference to call the record. So for this column, I'm going to call it ID. Okay. And for the type, this is going to be an integer. An integer, is a number. Um, if it's going to be like a number, then you have an integer. If it's going to be a name, you have a varchar. I'll provide some information about that also in the course room, but we're just going to keep it very basic. So this will be an integer, and then under index here, this is going to be my primary key. This is, remember, going to be as far as my unique identifier. Now, when you do this, this add index pop-up is going to appear. Just what you want to do is just check that the information is correct. So it is the integer, is the primary, and then just hit go. Um, and we want this column to automatically increment. So let me talk about that a little bit. So if you have an ID, a primary key that you're assigning its value, like if there's a student ID, a social security number, product ID, something like that, then you can add that value yourself as long as you know that it's going to be unique. But if, for instance, you aren't going to have some kind of unique number, then what you're going to do is you're going to create this, and then what you want it to do is you want it to automatically increment, meaning it's going to start with the number one, and then it's just every time you add a new one, it's going to be number two, number three, number four. So if you have a unique identifier, then use that. If you don't have a unique identifier, then you're going to create one and then assign it as the automatic increment. Okay. Um, Now, in my database, I'm creating just a database that would, again, be a person's database that would be maybe almost like a sign in or something like that, like would have like the different users in it. Um, so I'm going to have like a name that I'm going to give the ID of, call it a username. Okay. Now you need to kind of decide on some naming conventions for your different names. One rule is we do not use spaces. Okay. So if you have to break things up, if you really want to break things up, then what you would use is an underscore. We don't use asterisks. We don't use, ampersands, things like that. You just have letters and then numbers and like I said, a dash or an underscore. Um, but what I like to do is I've decided on my naming convention that's going to be like a lowercase and camel case lettering. So, you know, it won't um, it won't have any spaces, and you'll be able to kind of tell what the name is just by looking at it. So, like I said, it starts off with the lowercase and then it uses camel case. Again, you can have, like an uppercase U, you can have a dash, or something like that in it. But whatever it is that you decide, um, just maybe have that so that everything is named that way. You have that naming convention. And so again, the naming fields, you're going to use letters, perhaps numbers and underscores. Actually, no dashes or any other kind of symbol, in there, especially for MySQL. Okay. Now, whatever you use, you have to remember because you're going to reference this in your code. So, when I go to say integrate or when I go to connect my database and I want to call this field, I just need to remember that I've named it, username and it's case sensitive and that type of thing. Okay. Now, this is going to be a string. It's going to be, like a username. So I'm going to, as far as type, I'm going to select varchar. Okay, so if it's going to be a string, and again, we're just kind of keeping our database basic because this isn't really a database class. But if you're going to use some kind of text or something like that, then just say varchar. Now, as far as the length of most names is going to be 50. So I'm going to go ahead and say 50. That's how many characters, the maximum number of characters that I want to use in that particular field. Okay. Now, I also I'm going to have an age. Okay. In my persons. So I'm going to add user age. Um, and normally I would make this a numeric type, but I'm gonna just kind of keep it um, simple. So um, if you want to have something like this, if it's going to be a number, you can have an integer. But for me, I'm just going to make it a varchar just to make it simple. It's not like I'm calculating the age. I need to calculate the age or do anything with it. If it's a number that you're going to be using to calculate something, then of course you want to keep it as an integer. But for me, it's not going to be, anything like that. So I'm going to make it a varchar. And ages are usually, I mean, I don't know anybody that's more than 3 digits as far as 100 and something. So I'm going to say that the length is going to be 3. Um, and that's going to restrict the characters that I have, in that can be put into this particular field. Okay. And then for my last column, I'm going to reserve this for the last update date. Like what I may do with this, I'm thinking with this database is I'm going to be integrate, like have a form that's going to feed information into this database, and that's how it's going to add this information in. And so I want to know like when was the record last updated. Now, this is optional for you. You might not need anything like this, you know. With your table. So, that's fine if you don't want that, but I'm going to add that. So it's going to be last updated as the name. Okay. And for the type, I'm going to say timestamp. So what I'm going to do is it's going to actually update this with the timestamp. Okay. And then for default, I'm going to say current timestamp. So whatever time it goes to add a record to this particular field, whenever I add a record to this particular, I mean, a record to this table, it's going to put the current time, date and time, in this particular field. Okay, so with everything in there, I'm going to go ahead and click on Save. All right. Now you can always modify certain fields afterwards as long as, maybe the changes don't affect the, recorded data. Like if you've already entered data into the database, then it would be difficult to sometimes make certain changes. You have to really look to make sure that it's not going to affect any of the data in there. Okay. All right, so we're going to go ahead and insert a row or record in our table. Now we can use the Insert tab, that allows us to manually enter information, using a form. Okay, so I had suggested either using an insert command, um, or doing it manually. So I'm going to show you how to do it manually as far as entering. If you look at the instructions here, and what we're doing is, see, we've already created the table, and you can create it using the database manager. That's what we did, or you can use the scripts. And like for instance, I've given you the scripts, and I've actually given you like what the different fields are, which ones are going to be the primary keys and things like that. But we went ahead and we did it using the database management manager. We built ours doing the database management. Now, what you want to do is you just want to test your database, just to make sure that everything works correctly. Now, before we do that, one of the things you're going to submit is a screenshot of your database and its tables. So as you build each table, go ahead and do a screenshot of this. Okay, so once you build the table and you say save, then go ahead and do a screenshot of this. And then when you build the next table, do a screenshot. And when you do your third table, do a screenshot. And that's what you're going to submit as far as the screenshots, along with submitting the screenshot or the file of your ERD. That's the ER diagram that I showed you earlier how to do. So let's go ahead and insert a row. So we're going to go to Insert. Okay. And this allows us to manually enter, using a form. Okay. So here, this is where we would actually put our information in. Now, because that ID is getting automatically incremented, we don't have to do anything there. All we really have to do is enter information as far as the username and the user age. Now, the another way that we can do that besides using the form, and I want to show you this way because this is you're going to be, basically kind of writing as far as like, SQL to manipulate your database. So um, I want to help you through this, show you how to do it with this interface, writing actual SQL. So we're going to click on the SQL tab here. Okay, and this is how we run queries against our data in our database. The select statement is going to retrieve records. Either it's going to retrieve all the records or specific records. Insert is going to allow us to add records to our database. Update is going to allow us to change records. Delete is going to allow us, say, to remove a record from the database. This is also where you could have run those, if you wanted to use our SQL for creating tables, you could have actually run these within that so that you could create a table, create your tables. But again, like I said, what we did is we created our tables manually. Okay, so um, we're going to go ahead and click on insert here. Okay, and so that and it kind of writes out as far as we're going to ignore that. It's just because it's right now it's not formatted the way that we need to format it. Whenever there's an error or something like in your SQL statement, you'll get something like this. But again, this is not complete because it doesn't like these brackets, and we're going to get rid of those brackets, so that's not an issue. Okay, but this is the SQL statement that we use for inserting a record into the table. And again, we'll get into this a little bit more in the next module. Now, since we are having the ID automatically incremented, we don't need to insert that. So let's go ahead and remove that from our statement. Okay, so what we're saying is insert into, and it tells us what table it is. It's telling us what fields it's inserting into, and then it's telling us what values it's actually going to insert into those fields. Okay, so we're going to remove that because we're gonna automatically have that. And the same for the last updated. Remember, that's going to actually take it from the current timestamp, so we don't need that. So this means that we only have these two values, okay, that we're going to be inserting. And remember to enclose them into the quotes, because they're going to be, when we put the value here, they're going to be varchar. So, numbers we wouldn't have to put in quotes, but for varchar, because they're strings, we need to put them in quotes. So we're going to put the um, two values for username and for user age. Okay, so again, my quote, I'm going to say Marley Civils, then comma, and then I'm going to say 7. Okay, all right, so that's all I have to do. I'm inserting into these fields these two values. And again, that's why I've got the quotes here, because so it'll know that it's inserting this string. And then because age, remember I made age a varchar. If I hadn't made it a varchar, if it was just an integer, I wouldn't need these quotes. But since I made it a varchar as a string, then that's why I need the quotes. And then I'm going to go ahead and click on go. Okay, and then it says here, I got a green, meaning that it inserted a row. Okay, so it's inserted that information in there. Okay, so now all we need to do is go back to browse, and we can see as far as the record that's in there. So it put the ID in there because we said that was automatically incremented. We've got our username, we got our user age, and then that last update was automatically in there. Okay, so you're going to do this you're going to create the 4 tables, okay, and then you're going to maybe put some sample data just to, you only have to do it to 1, but that's just going to test your table just to make sure that you configured it correctly. Now, if you want to see all of your tables, see right now, see how this is kind of doing a breadcrumb up here? So right now we're looking at our persons table. If I click go back 1 to the database, then it'll show me as far as my tables that I have. So right now I just have the person's table, and then if I want to look at that table, I click on browse and it'll take me into that table, and then, I can do different things I want with it. Now, like I said, you can build out manually, or you can use um, the SQL that I've provided you to actually build out your table. So for instance, we'll copy this. I'm going to create this using SQL, an SQL statement. I'm going to create this table. So, just make sure this is what you want. Right now, the way that I've got it designed is that it's going to create this primary key, auto increment, of course, called ID. It's going to have a name, which is going to be a varchar with a length of 100. It's going to allow for me to put a date in there. So that's a different type of date, that different type of data type. And then I'm going to have a location, which is also going to be a varchar of 100. So I'm going to copy that. I'm going to come back over here. I'm going to go under SQL, and then I'm going to paste that in there. Okay. And then I'm going to hit go. Okay. And it says, it created a table, empty table set. So now if I go back to structure, I see that it created that second table in there. Again, just watch your name. See, I don't have the same naming convention. So, that's something I would have done before I actually created the table. But that's another way. If you don't want to manually do it the way that, we just did it, actually building it out, then you can use my SQL statements here. But like I said, change the names using the naming conventions that you're going to be using. Don't just, copy and paste it as is. Okay. And if you make a mistake with the table, and you want to, change the structure, or if you want to drop it, this is the structure here. I can go in and I can do changes to it. Like I said, as long as I haven't put any data in it, I can go ahead and make changes to it, all I want, you know, or if I don't want the table, if I want to just kind of redo the table altogether, then I can just go in and I can drop that table. That's like deleting the table, and then it's gone. So, like I said, you're going to do the screenshots of after you build the tables, and you let me see the structure of the table. So basically, if we go in here and say browse structure, this is what, I'd like to see. If you can remember that, this is what I'd like to see, so I can see the structure of your of all three of your tables that you do. If you have any questions, again, I'm going to try to provide as many resources as I can, but if you have any questions or you need to meet with me or something like that, please just reach out to me via email, and I can help you with this. Other than that, have a good day.